Hello, everybody. My name is Fred Dauber. Um, I want to spend a few minutes giving you an overview of how we integrate wireless locks on our MAP1 controllers. Uh, it's worthwhile knowing how the pieces go together because then it will make a lot more sense and you'll be able to see how you can build systems using any mix of wire and wireless locks on any of the three solutions that we have. So what I'm showing you here is this is an architecture for a regular wired MAP1. MAP1, as you know, can support a maximum of 4 readers. Inside of MAP1, there's 2 boards. Program logic module, which is really the brains. It's where all the database exists and the card holders and dates and holidays and all of that information. The PLM connects to the LAN and from there up to a server uh, of one form or another, and there are 3 choices, which it will be showing you. The other board that's inside MAP1 is an IOM. The IOM's job is to manage all the low-level I/O. Each of these 2 boards are separate. They have their own processor memory and their own code running on them, and they communicate with each other internally on a serial bus using a proprietary Cansec protocol. The IOM and the standard MAP1 has weekend readers connected to it. It has inputs connected, outputs connected, basically all the IO related things that are associated with the readers on those doors. So for instance, when you come up to a door, you present a card to a reader, that data goes to the IOM. He collects the data together, creates a data packet, puts it on the serial bus, ships it up to the PLM. PLM will then look up that card number, check the reader you used at the time, date, status of the card, and if all is good, it will then send a command back down to the IOM to release the strike on that particular door. Similarly, if a door contact switch changes status or someone presses a request to exit button, the IOM detects it, bundles it up in a package, ships it up to the PLM, and off you go. The nice thing with this is the workload is spread between the two. That tends to, well, it helps to improve performance. Um, so keep in mind sort of the overall architecture of that when I take you now to the next slide. This is basically what a MAP1 looks like inside that is provisioned with support for wireless locks. You'll notice there's the PLM module. It's the same PLM module running exactly the same code as on the wired reader MAP1. The big change is that the IO module, or IOM, has completely new firmware written for it. The IOM, in addition to supporting a bunch of readers and input outputs, it has an RS-45 port. The IOM communicates with up to 4 AH30 wireless hubs. The wireless hubs in turn then talk to the wireless locks. The magic here happens in that the IOM module is still doing the same role. He's managing all the low-level I/O, so the PLM doesn't have to worry about it. And the way it's done, which is kind of clever, is that the IOM with Aperio firmware makes everything happening with the wireless locks look just as if it was happening with wired locks. So when it communicates a door contact change of state, a weekend card being presented, the packet that it creates and ships up to the PLM looks to the PLM to be exactly like that packet coming from wired readers. A point in passing here is that when you have a MAP1 provision for Aperio, you cannot also have wired locks associated with it. If it's a wireless lock MAP1, you only get to support the wireless locks. One of the things you'll notice here that's a little different is that The MAP1, when you've got wireless locks connected to it, is able to support 8 readers. When it's got hardwired, it can only support 4. The reason for that is there's only enough room to terminate 4 readers and all their I/O with hardwired stuff. There is no other place to terminate. When you're communicating with all the readers via the 485 bus, that's the only connection that is made, and therefore I'm not stuck with the hardware limitation of only 4 readers. I can now support 8. The reason also why that's possible is that, as luck would have it, the database inside a MAP1 is identical to the database inside of a MAP2. A MAP2 is an 8-reader panel, and it has therefore a database to support 8 readers. When we made the MAP1, which is we did after we made the MAP2, we kept the same database structure. So a MAP1 actually has an onboard database for 8 readers. That worked out great when we came to integrate the wireless locks, and that's why it's able to support 8. The important thing to note here is that from the PLM up to the server, both of them look the same. The PLM module on the wired and the wireless is identical. So to the server side, they look exactly the same. Now, why is that a useful thing? Well, it's a useful thing because of this. One of the whole concepts with the modular access panels is there's a family of them. MAP Mini 1 door, MAP 1, that can be 2 or 4. It can also be wireless and support up to 8, and then a MAP 2. Those 3 controllers can be used on any of the 3 servers, one of which is the new Webster 64. Webster 64 controller can be provisioned for 2 or 4 doors on board, hardwired readers. You can connect up to 31 MAP Minis, MAP 1s, and MAP 2s in any mix you want, up to a maximum of 64 doors. And because the MAP 1's hardwired and the MAP 1 with Aperio look identical, you can mix and match them in any way that you want. Similarly, those controllers could be connected to First Access on-premises server, or they could be connected to a First Access cloud server. And again, same idea is the wired MAP 1s and the wireless lock MAP 1s look identical, so you can mix and match them in any way that you want. One important thing to note here is the way that we handle the wireless readers. Basically, we use the wireless readers in a very dumb fashion. Well, we don't use them in a dumb fashion, we make them dumb. Basically, we used the wireless locks to collect the weekend data, get it shipped up to the PLM for the decision, and the decision is made at the MAP1 PLM. We then send a command back, which will go to the IOM on the internal bus, out on the wireless hubs, and back out to the reader. So there's no data. We do not store any data on the locks. We use them to collect the card data in real time and sense the status changes in real time, send it to the IOM with the special firmware up to the PLM. It's processed in real time, and if something needs to happen back at the lock, the MAP1 will make the decision, send a command back downstream, and it'll go out to the lock and either unlock or flash the lights or do whatever is appropriate for the transaction. One of the upsides with that is that when you're managing a mixed environment, you're treating them all the same. There's no worry about, well, these are wireless locks. They can only have 10,000 card holders. These are hardwired. They can be 100,000. By treating the wireless locks as dumb, no disrespect intended, it means the wireless lock capacity is 100,000 cards, the same as wired. So from a user standpoint, and where you're the system manager, you can treat them all identically. You don't have to ever know or care or worry about whether, oh, these ones are wired, these ones are wireless. I need to do something different and treat them. They're all treated exactly the same. So basically, that's the whole story. I hope you enjoyed it. And if you have questions, you know where to find us. We'd be super happy to answer them for you. Take care and have a great day.